Hello friends, welcome back to the next lecture of the JSE Connect series of online lectures. We are into module 5 and dealing with the concept of transmission length. In the previous video, we have understood what is a transmission length, what is its importance. Even we have discussed few IS code regulations or recommendations for reducing the transmission length, and most importantly we have discussed the factors, the 10 factors which impact the transmission length. So in today's lecture or in the next lecture, now let us discuss further things about transmission length. So first let us start with the empirical formula for calculating the transmission length. The empirical formula LT stands for the transmission length, is equal to square root of FCU into 10 raised to 3 divided by beta, where FCU is the cube strength of concrete at transfer expressed in Newton per mm square, that is FCI what we are using. LT is the transmission length in mm. Beta is a constant depending upon the details of strand and wire. The values of beta for some typical wires and strands are compiled in the table. So if you get this example, the beta value will be mentioned in the problem and it becomes a straightforward example. It is asked for 4 to 6 marks. So now let's see how the beta, which is a constant, varies. So we have nearly 8 parameters. Okay, initially is a 2 mm diameter wire, 5 mm diameter wire, 7 mm diameter wire. That means the beta value varies upon the diameter of the wires. So we have wires, we have combination from the fourth 10 mm diameter 7 wire strand, 12.5 mm diameter 7 wire strand, 18 mm diameter 19 wire strand. So these are some of the standard combinations which are used in case of PSC. As we talk about RCC, we use the standard bar combination 216, 212, okay, or 4 bars of 12 mm diameter. So these are such combinations which are worked out for which the beta value is given. So you need not by heart the table, the beta value will be mentioned. Then the 8th parameter here is twisted wires of or 6.2 mm diameter 7 wire strand. So these are the combinations and the beta values are given in the table. Okay, so you have to just take the value of beta and substitute it. Then next comes Hoyer's equation for computing LT. This equation is a bit complicated and a bit bigger one, and examples may be asked on this equation also. So with the given data you will be able to judge, okay, which equation, whether the empirical formula or Hoyer's equation is expected. So this equation reads as LT is equal to phi divided by 2 mu into bracket 1 plus Vc into bracket alpha E divided by Vs minus Fpi divided by Ec multiplied by Fpe divided by 2 Fpi minus Fpe, where the terms are listed as below. LT is the transmission length, phi is the wire diameter, mu is the coefficient of friction between steel and concrete, Vc is Poisson's ratio for concrete, Vs is Poisson's ratio for steel, alpha E is the modular ratio, that is Es by Ec, Ec is modulus of elasticity of concrete, Fpi is initial stress in steel, Fp is the effective stress in steel. Okay, so many parameters are considered, hence a simpler formula was the previous one by which we can compute LT. So these two formulas will be required for the computation of the transmission length. So let's take one example each on these both formulas. So example number 1, calculate the transmission length at the end of a pre-tensioned beam as per Hoyer's method using the following data. So now here data will be long and big as the formula is big. Span of the beam is 50 meters, dia of the wires used is 7 mm, coefficient of friction between steel and concrete is 0.1, Poisson's ratio for steel is 0.3, Poisson's ratio for concrete is 0.15. ES is 210, EC is 30. So ultimate tensile strength of steel wires is 1500 Newton per mm square. Initial stress is 0.7 times of FPU. Effective stress in steel is 0.6 times of FPU. Okay, so this is what is the given data. So many times what happens is, the difficult task here is to remember the formula. Once you remember the formula, then this sum is very easy because it is straightforward substitution example. So now let's apply the Hoyer's equation. Substituting all the values, we get LT as 100 times of the diameter, which is nothing but 700 mm. So if the beam is simply supported over a span of 50 mm, there should be at least 70 mm of the beam projection beyond the center of the support at each end. Therefore, the total length of the beam required to be casted at the site is given by 50 plus 2 into 0.7, which is equal to 51.4 meters. Now this can be related, as we are taking the entire length of 700 mm, it can be a fixed beam also. For recommendations for simply supported beam are LT by 2, but still to be on safer side and to avoid any transmission length in the span, initially itself we can take the overall length of the beam as 50 plus 2 times, okay, of 700 mm. 2 times means at the either end, which comes out to be 51.4 meters. So this is how you calculate the value of transmission length using Hoyer's equation. So again I am repeating, these are straightforward examples. The task or the challenge with you all is to remember the formula and substitute the right things at the right place. So once you practice, this formula becomes quite easy. So let's take up one more example. Example number 2. Estimate the transmission length at the end of a pre-tensioned beam prestressed by 7 mm diameter wires. Assume the cube strength of concrete at transfer as 42 Newton per mm square. Adopt Krishnamurthy's empirical relation. So finally we have found one Indian name, Krishnamurthy, who has suggested the equation which can be used. So this is nothing but your empirical relation. Okay, so it is Krishnamurthy's empirical relation, which we can use directly to find the required things. So LT is equal to square root of FCU into 10 raised to 3 divided by beta. So for 7 mm diameter smooth wires, beta is from that previous table which we discussed. We can take the value of beta. FCU is equal to 42 Newton per mm square. So let us substitute these values. LT is equal to square root of 42 into 10 raised to 3 upon value of beta, which we have taken as 0.0174. So which gives us an answer of 610 mm. Okay, which is 87 times of the diameter. If on the other hand 5 mm diameter bars are used, then okay, this is one more variation shown in the same problem. Beta value is 0.0235 in this case, and we get LT as 525 mm, okay, which is 105 times the diameter, which is 5 mm in this case. Okay, so two variations in one example itself are shown. This was once asked for 4 marks, a simple straightforward substitution example. Now these 4-5 marks, okay, 6 marks become very important with respect to your grand value or the grand total of achieving 28. So don't neglect any part of it. Now with this we have nearly covered from all the 5 modules maximum of the concepts or the attemptable things. Generally in the theory classes we used to rarely get time to go beyond this. Even for the last batch it was difficult for us to cover even these concepts. Okay, so up to here we have tried to cover maximum of the things. it is a new subject, like you require quite some understanding. Each chapter is different. It is not similar to RCC where once you have by-hearted the formulas and the steps are followed. Okay, each chapter has concepts which you need to understand and go ahead. Still further, I think we'll be putting up the composite sections, and even we'll try to cover the design of a beam, or at least share proper notes of those concepts. So we hope that you have started to study properly, and if any things are there, if you have not understood, we had lot of time which we are told, like, come back to us and ask. Still, if you have not asked and once the exam dates are announced, then your hurry starts. So I request you all, still we have 15 days for the closing of the semester, and maximum of your averages are done in the 2 IAs. But as a formality, we'll be having your first IA wherein you have to write and submit the PDFs, which is not a big task. Start studying module wise. Okay, so if your dates of exams are announced, don't wait for that announcement and all. You are in final year. Each and everything you learn here will be application. Let it be this subject or let it be estimation, because PSC will be the future. Slowly RCC will come down and PSC will take over it. So if these basics of PSC are clear to you all, it will be very nice for you all in the field. Hopefully these are the last few interactions or the classes. You understand why we are telling these things. Okay, so thank you once again. In the next lecture, we'll start with the composite sections. Thank you.